Good afternoon, everyone. Dear students, in our last lecture, we learned the different observations related with experiment on photoelectric effect, that is experimental study of photoelectric effect. Near about 5 observations we have seen, including first related with frequency, second it was related with intensity, third it was related with instantaneous phenomenon, then it was related with stopping potential, and another was related with again variation of intensity. So we have to learn the remaining 3 observations like this. There are again 3 important observations from experimental study of photoelectric effect. So we have to discuss the observations from experiment on photoelectric effect. In last lecture we discussed about 5 observations, we can say in another words characteristics of photoelectric effect. The remaining 3 we have to learn in this section. So see here, 6th characteristics or 6th number observation on photoelectric effect. So the fixed frequency, for the fixed frequency of incident radiation and accelerating potential with incident radiation of different intensity, the saturation current increases but the stopping potential for the metal surface remains same. These we have discussed also separately, including that 3 diagram variation of different intensity with different potential difference. Here what does this observation says? For fixed frequency of incident radiation and accelerating potential, means which 2 quantities are kept fixed? The frequency of incident radiation, which is greater than threshold, it is kept constant, and accelerating PD, that is position of rheostat, is kept constant. Instead of using one intensity source, if we use different intensity radiation, means 2 to 3 radiations, and we observe the increase in current and also the stopping potential. See here graphically we can represent this as, how we can represent graphically this part as, see here. So this is y-axis, this is x-axis. On x-axis there is positive potential, on here y-axis there is negative potential, and on this there is on y-axis there is photoelectric current like this. So what we have to keep constant? Frequency of incident light is kept constant, and alternating accelerating PD, this PD is also kept constant, just we have to change the different intensity sources. If we take first intensity source, in last lecture also we discussed about intensity. Even for 0 potential difference, it is 0 PD or potential. Small current flows, and if we go on decreasing, we start here graph from this point, the stopping potential remains constant, but so this is for 1 intensity. Second, this is for second, and for third one see here, this value is stopping potential, which is remaining constant. This is for intensity 3. This is for second intensity. And this graph is for first intensity. So it is clear now. What I want to see here, for fixed frequency of incident radiation and accelerating PD with different intensity radiations of different intensity, these are a different intensity. What happens? The saturation current increases. These are saturation current, maximum values, these are different. This is I1, this is I2, this is I3, it is I3 is greater than I2 is greater than I1. Similarly, this E3 is greater than E2 is greater than E1. But what happens if we go on decreasing the stopping or retarding potential here? It is observed that all these three graphs or three curves meet at a point on negative x-axis, which gives us the same or constant negative potential, that is stopping potential. So the stopping potential for metal surface remains constant, but saturation currents increases, means here I3 is greater than I2 is greater than I1. Also E3 is greater than E2 is greater than E1. But same potential, but negative potential decreases and it reduces to this value for each one. For each graph, this negative stop potential remains constant, just saturation currents are different. So this is the 6th number observation. So it is clear that how the intensity can change the saturation current. Now next one, see here, 7th or last but one observation. For fixed intensity of radiation and accelerating potential with the incident radiation of different frequency, the saturation current remains constant, but the stopping potential decreases. This also we have discussed separate, taking separate condition with the help of neat graph for fixed intensity of radiation and accelerating potential. Again, which quantities are kept constant? The intensity of radiation is kept constant and stopping potential is also kept constant. What we have to change? We have to change the accelerating PD, but that also negative. Accelerating PD is also kept constant, intensity is also kept constant. We have to use different frequency radiations. So this is y-axis on which we have to measure current. This is photoelectric current. Here it is positive x-axis on which we have to take accelerating PD, and here on negative x-axis we have to take different V0, that is stopping potential. What happens to this now? For different frequency we get the different curves having different stopping potential but the same saturation current. This is the saturation current. This is for one frequency. We can say this as for nu 3. Next, for another of smaller frequency, we get the same saturation current. And finally, for first one with smaller frequency, we get the same saturation current. So this is intensity of incident radiation and accelerating potential kept constant. This is one intensity. Here are different frequencies. This is nu 2. This is nu 1. So this is for first frequency. Stopping potential is here V1, we can see it is negative 1. Here it is V2 and here it is V3. See here are different stopping potential, but same saturation current for fixed intensity, but for different frequency the stopping potential get different. Means we can say that stopping potential depends upon frequency. Here is a relation between stopping potential and frequency of incident radiation. So stopping potential depends upon frequency, it is independent of intensity, and before that current was dependent on intensity for fixed frequency, for fixed PD. Here for fixed intensity of radiation and accelerating potential with incident radiation of different frequency. Here are different frequency incident radiation. Nu 3 is greater than nu 2 is greater than nu 1, and for that we get the same saturation current, maximum current becomes same, but we get different stopping potential. V1 which is less than V2 which is less than V3, that is V01, V02, V03. So these are different stopping potentials for different frequencies. So this was seventh and last but one observation or characteristics of photoelectric effect. Now we have to discuss last characteristics. So last characteristics is now the kinetic energy of ejected electrons depends upon frequency of incident radiation. It does not depend upon the intensity. See here, this is again the most important conclusion from this experimental study of photoelectric effect. Actually, we have to discuss this in Einstein's photoelectric effect. So what is kinetic energy of ejected electron depends upon frequency, means we can write this relation as the kinetic energy of incident radiation this kinetic energy of incident radiation is directly proportional to frequency of incident radiation. So the kinetic energy of ejected electron depends upon the frequency of incident radiation and does not depend upon intensity. In first article, while studying photoelectric effect, we discuss a diagram where we use three different colored light: red light, green light and blue light. In that I have shown that how the maximum speed increases from green to violet. For red light it was 0, means no emission takes place. For green light emission starts with 2.96 something 10 to power of 5, and for violet light, the speed of emitted electron was again greater as compared to previous one, means which quantity increases? Kinetic energy. So kinetic energy depends upon frequency, it is not, or it is independent of intensity of incident radiation, and this is actually contradictory part between particle theory and wave theory. That also we have to discuss in failures of this theory. So this is the total explanation for observations from experiment on photoelectric effect. So in next lecture we have to discuss the different definitions